Okay, operations with monomials. Okay, first of all, we need to understand some vocabulary here. First of all, the word term. The word term refers to a number, variable, or a combination of both connected by multiplication or division. Or division. Okay, that's what a term is. So here's some examples of terms. 6x, 6x squared, 6 times x plus 3, x plus 3 divided by 6. As you notice, these are just very simply one term. There's no things that make it kind of confusing. This one, we have an addition inside of parentheses, and the 6 multiplication here connects it together, making it one term. Here the same thing happens with division. So these are all one term. So what happens then when we start thinking of monomials? They're one term. A monomial is one term. We might as well do this too. A binomial, bi means two, mono means one, so a binomial is two terms. And a trinomial is three terms. Okay? So you need to understand mono is one, bi is two, and tri is three. These are the most common of these names that we use. The others have names, but we usually don't use the names. We'll say 4 terms or 8 terms or whatever. They can actually have names like this, but we don't use them very often. So we'll just go mono, bi, and tri. Okay, a term or a monomial is made up of a coefficient, often, these are the 3 things possible: coefficient, variable, and possible exponents, or more than one variable exponents. Okay, so those are the things that we look for in terms. So let's look at some examples and exactly what that means. The coefficient is the number which multiplies the variable. And it is always written before the variable. Written first. Okay? That's your coefficient. The variable refers to the letters that are part of the term. And the exponents are the powers assigned to variables. We can also refer to a degree of a term. A degree of the term may be the same as the exponent or may not be. So the degree of the term is the maximum power of the term. And we'll look at that in a bit. So let's look at a monomial. Here's a monomial, 6x squared. So what is the coefficient? Your coefficient is the number 6. The variable is x. The power, or the exponent, is the number 2. Okay, so here's your power or exponent. Here's the exponent base, and here's the coefficient. Now in this case, the degree of this is exactly the same as the exponent. The degree of this term is 2. Now let's look at another monomial. 6x squared y to the third. Okay, in this case, we have 2 bases, so we don't have a power of that term. Instead, we have a degree of the term. My coefficient is 6. My variable is x and y. I have 2 of them. The power of my x is 2. The power of my y is 3. So these are the powers. But it's not a power of the whole term. Whereas the degree of my term, in this case, is 2 plus 3. So the degree of this term is the number 5. And that's where your power or your exponent differs from the degree of the term. Okay? So that's what you're dealing with. And we can label all these things for whatever terms we come up with. So let's look at the operations of these things. Add and subtract are simply nothing more than combining like terms. Okay, 6x squared plus 9y plus 10 plus 8x squared minus 15y minus 40. Combining your like terms gives you 14x squared plus 9y minus 15y is a minus 6y, and plus 10 minus 40 gives you a minus 30. So you see, this goes back to about the 3rd lesson in our semester. All you're doing is combining like terms when you're adding or subtracting monomials. It's something we've already done. It's nothing new. Just have to make sure your base is the same, your exponent is the same, so that you have like terms. So now what happens if you multiply? We're not going to do the division today. We're just going to look at multiplication. So multiplication of monomials. And you will see it's exactly what we just did using our power rules, our exponent rules. So, multiplication, 6x squared y cubed times 4x to the 5th, y to the 2nd. Look, 6 times 4 is 24. X, same base. Add my exponents, so 2 plus 5 is 7. Y times y, so we have multiplication, same base, and 3 plus 2 is 5. So you can see your multiplication is exactly the same thing if we're doing a monomial times a monomial as it was when we did our basic power rules, our product rule. Now, actually we can do division too if we're doing monomials. So, if we look at division with monomial, let's do 12x to the 4th, y to the 3rd, divide by 6, x to the third, y to the sixth. Notice, same thing, same base, same base. So we have 12 divided by 6 is 6. X to the third, x to the fourth is larger than the 3, so I'm going to do my subtraction on top and get x. But y to the third, y to the sixth, my 6 is larger, so I'm going to do my subtraction in my denominator, making y to the third. So you can see, all that is your basic rules that we just did with our power rules and our product rule and our quotient rule for exponents if you're dealing only with monomials. But what if we have a multiplication of a monomial times something like a binomial? Then it's a little bit different. If I have 6x squared times 4x to the fifth plus 9x to the third minus 5x minus 10, okay? Now you're dealing with a distributive property. And so you're going to be multiplying monomial times monomial, monomial times monomial, monomial times another monomial, and a monomial times another monomial. So this is going to end up with 24x to the 2 plus 5, which is 7, plus 6 times 9 is 54, x to the 2 times 2 plus 3, which is 5, minus 6 times 5, which is 30, and x squared times x to the first is going to give you x to the third, and minus 6 times 10 is 60, x to the second, because this x would be x to the 0, which is never written. Okay, so now there's nothing that is like, there's no like terms, so that would be your final answer, multiplying a monomial times something with more than one term inside the parentheses. So there you have it. That's how we use monomials.